the OH-6, the highest performance light observation helicopter in the Army's inventory. You will soon be flying this LOH. Obviously, the OH-6 is a fast, powerful, responsive, and stable aircraft. Let's see what gives the aircraft these desirable qualities. The OH-6 is small. Its total length from the forward edge of the rotor disc to the trailing edge of the tail rotor disc is just over 30 feet. Its rotor diameter is slightly more than 26 feet. This compactness gives the OH-6 excellent close-quarters maneuverability. The aircraft has clean lines. The teardrop-shaped fuselage is the result of wind tunnel testing to provide minimum drag. Even the landing gear struts have fairings to reduce aerodynamic drag. The clean lines of the OH-6 are part of the reason for its speed and stability. Another contributing factor is the powerful, lightweight turbine power plant. The small turboshaft engine weighs only 136 pounds. Its military rating is 317 horsepower, but installed in the OH-6A, it is derated to just over 250 horsepower. This favorable horsepower-to-weight ratio adds greatly to the OH-6A's speed, power, responsiveness, and stability. The engine, like most of the aircraft's major components, can be quickly removed and replaced under field conditions. The engine's power is not wasted in carrying and operating a heavy and complex main and tail rotor drive system. The engine drives a total of only 4 gears in the main transmission, with 2 gear meshes. In the tail rotor gearbox, there are 2 gears and 1 gear mesh. The tail rotor drive shaft is one piece, lightweight and dynamically balanced. It has no supporting bearings and no universal joints. The simplicity of the drive system provides lightweight, low power loss, and a minimum of maintenance. The 4-bladed rotor system produces high lift with very little vertical vibration and rotor feedback. The blades are retained on the hub by laminated stainless steel straps. Each of the strap assemblies holds 2 opposing blades. These blade retaining straps have many unique advantages. The principal one is that they provide both flapping and feathering without the heavy joints and thrust bearings used in conventional rotor heads. Since much more force is imposed by flapping than by the centrifugal force of blade retention, broken straps will usually cause an out-of-track blade condition long before there is any possibility of blade loss. Thus, the blade retaining straps provide full articulation, freedom from joints and bearings, with minimum maintenance required. Each of the blades is a friction-type damper connected to the blade root through a damper arm and attaching pin. These dampers serve to restrain lead and lag motion and keep the blades an equal distance apart. No components of the rotor head requires lubrication, and on the OH6 there are only 3 sight gauges, one each to check lubricant level in the main rotor transmission, the engine, and the tail rotor transmission. Before each engine start, the blades and dampers must be rephased by pushing each of the blades forward in the direction of rotation, as the tail rotor is held firmly. This resets the dampers to their minimum friction setting and spaces the blades at equal intervals around the hub. This is also a good time to check the condition of the main rotor blades. The aircraft has been specifically designed to avoid the need for boost or automatic stabilization equipment. It consists of simple bell cranks. And push-pull tubes. No lubrication is required on any of the joints or bearings in the entire flight control system. On each cyclic control, there is a cyclic trim switch, which is used to electrically adjust longitudinal and lateral trim force. The cyclic system also contains a one-way lock, which resists aft stick movement. On each of the collective pitch sticks, there is an N2 governor trim switch. This switch permits the pilot to control N2 speed within governor range. With engine speed control, cyclic trim, and the cyclic one-way lock to resist rearward cyclic force, the OH6 is a very comfortable, stable aircraft to fly. The tail configuration also lends it stability. The stabilizers are almost as large as those found on small fixed-wing aircraft. At cruising speed, the horizontal stabilizer provides longitudinal stability. The vertical stabilizers contribute directional stability. The real proof of stability lies in flying the aircraft. Its stability permits hands-off flying in straight and level flight. Yet the OH6 is agile and handles very much like a well-designed fixed-wing aircraft. Next, let us look briefly at the construction of the fuselage. The primary structure of the OH6 is a strong central A-frame formed by the bulkheads fore and aft of the cargo compartment. The main transmission and rotormast are at the top of the A. Thus, the cargo, armament, or passenger load is carried directly beneath the main rotor. Because of this, weight and balance, or CG problems, are seldom critical. The landing gear struts are connected to the trusses through shock absorbers, which reduce landing shock. And transmit the landing gear load to the fore and aft trusses. Beneath the A-frame is a wide keel beam which extends the entire length of the fuselage. This further strengthens the primary structure. The flight compartment seats, as well as shoulder harnesses and seat belts, are attached directly to the primary structure. The engine is attached to the rear of the A-frame. Thus, all critical components, including the engine, transmission, and rotormast, seats and pilot are directly attached to the strong A frame structure. In the event of a crash, the secondary structure is designed to crush and absorb high impact loads. While the outer surface absorbs the impact. The passengers are protected within the A-frame, and the flight compartment is protected from collapse by the height of the A-frame and the forward extension of the keel beam. The aircraft has provision for mounting armament kits on the left side. The machine gun kit consists of a 6-barrel minigun with selective rates of fire. Ammunition is carried in a narrow box near the forward bulkhead. A mechanically linked gun sight is used for aiming the minigun. The weapon is operated by a trigger and a gun elevation switch on the pilot's or co-pilot's cyclic stick grips. The OH-6 cargo compartment has provision for 2 folding seats for passengers. Without a co-pilot, seats are available for 3 passengers. However, 2 additional passengers can be carried if the standard passenger seats are not used. With an armament kit installed, a total of 4 passengers can be carried. Though the OH-6 is intended primarily as an observation aircraft, it is capable of performing many utility missions to small units. The OH-6 requires a minimum of maintenance. All major mechanical units are field replaceable by unit mechanics. But to an aviator, of course, the key question is, how does it fly? We will start at the beginning with hovering flight. As with any turbine helicopter, takeoff to a hover is started with collective pitch full down and throttle full open. While watching the N2 tachometer, the N2 governor is adjusted to operating power turbine RPM. Cyclic control force is trimmed to neutral with a cyclic trim switch. As collective pitch is increased, you will discover that the OH-6 is different. There is practically no turbine lag. Response to increased power demand comes in less than 1 second. Hover at about 3 feet and fine trim the cyclic control force to neutral. Check the instruments for all readings in the green and check the flight controls for proper response. A professional helicopter pilot will always make these hovering checks, even though he knows the aircraft will check out, because he also knows that it's better to discover control binding or instrument redline at a 3-foot hover than during takeoff. In making hovering turns, there is one caution which should be observed in the OH-6. Turns should be made slowly, especially when turning the tail into the wind. If moved too quickly into the wind, the large horizontal stabilizer can produce considerable lift. If through misjudgment you feel the tail rising during a hovering or low airspeed turn, you will have to apply positive aft cyclic to regain a level attitude. Sideward and rearward hovering flight must always be performed with caution. Aviators and other aircraft and personnel on the ground have no warning of your intention to move sideward or rearward. Always make a clearing turn. In the OH-6, you will find that it is dangerously easy to develop too much speed in sideward or rearward flight. The reason for this is the exceptionally low drag of the fuselage. Proceed cautiously and very slowly until you are completely familiar with the aircraft's characteristics. In actual operation, Rearward flight is not good practice for moves of more than a few feet, but it is excellent as a practice maneuver to give you experience and confidence in maneuvering the aircraft. When you have gotten the feel of the aircraft and hovering maneuvers, you are ready for normal takeoff. Takeoff from a hover permits you to check controls and engine and instruments, as well as to make a clearing turn. With a twist grip in the full open position, smoothly apply cyclic to start forward movement. And maintain your 3-foot altitude with collective pitch. Accelerate forward until you gain effective translational lift. As the aircraft starts to rise, attain an attitude which will provide an airspeed of 60 knots. Establish the desired rate of climb by adjusting power. Power requirement will, of course, depend on your load and density altitude. As a general rule, the OH-6 can make a normal takeoff under any conditions of load and density altitude where it is capable of hovering at 3 feet. Takeoff from a hover is the normal procedure. However, takeoff directly from the ground is an accepted form of normal takeoff. Since takeoff from the ground does not permit a clearing turn, it is essential to check thoroughly for other traffic. To initiate takeoff, center the cyclic and apply collective pitch to extend the struts. As the aircraft becomes light on its skids, gradually increase collective pitch. The OH-6 will start to accelerate forward. For a perfect takeoff, you must establish a rate of climb and acceleration which bring you to an altitude of 3 feet and into effective translational lift simultaneously. Takeoff power should be maintained until a safe autorotative airspeed and altitude is reached. As soon as a smooth rate of acceleration is achieved, stabilize airspeed and engine torque. We will not spend time on the standard flight maneuvers, straight and level flight, climbs, descents, level, climbing, and descending turns. Your skill in other aircraft can be readily applied to the OH-6. Cyclic trim should be adjusted for the desired cyclic stick cruise position. Trim is correct when small controlled displacements in any direction require approximately the same force. N2 may be trimmed within the green to provide the best comfort level. The OH-6 cruise speed is fast compared with other light helicopters. It can easily keep pace with larger, more powerful rotary wing aircraft. The OH-6 maneuvers easily and control pressures are light. Normal approach and landing in the OH-6 is made with a standard rotary wing technique. Entry altitude approximately 300 feet above terrain, airspeed 60 knots, N2 RPM in the green reading. When an approach angle of 8 to 10 degrees is intercepted, reduce collective pitch to establish and maintain your angle of approach. As you approach, you will reach a point where ground speed and rate of closure seem to increase. This is the point to start decreasing forward speed. Maintain forward speed at about the pace of a brisk walk until the aircraft begins to lose translational lift. At this point, reduce rate of closure and airspeed to stop both descent and forward movement over the intended landing spot. Because of the aircraft's low drag, you may find a tendency to float right past the intended spot. You'll learn to correct this with a little practice. After a few hours, you'll really learn to appreciate the fine qualities built into the OH-6. The OH6 is small and compact, giving it excellent close quarters maneuverability. Its teardrop fuselage and freedom from projection give it exceedingly low drag. Its 136-pound, 317-horsepower engine give it more than adequate power. Its simple powertrain is light in weight, with low power loss and minimum maintenance. Its flexible stainless steel blade retaining straps provide feathering and flapping without bearings or joints. It has only 3 sight gauges. Transmission, engine, and tail rotor. It has no hydraulic system, and it has no grease fittings. It has a simple flight control system without boost or ASE. Its large stabilizers provide longitudinal and directional stability. It can be trimmed to fly hands-off. It is stable and agile, with quick and positive response to flight controls and throttle. Its fuselage is built around a sturdy A-frame and deep keel beam to which all major components are attached. It mounts a machine gun kit. It responds quickly and easily in hovering maneuvers. It must be hovered sideward and rearward cautiously. With its clean lines, excessive speed can easily be gained. Its takeoff requires no unusual procedure. And its approach and landing is equally simple. It is a small, powerful, highly maneuverable, and very useful aircraft. £36. Its military rating is 317 horsepower, but installed in the OH-6A, it is derated to just over 250 horsepower. This favorable horsepower-to-weight ratio adds greatly to the OH-6A's speed, power, responsiveness, and stability. The engine, like most of the aircraft's major components, can be quickly removed and replaced under field conditions. The engine's power is not wasted in carrying and operating a heavy and complex main and tail rotor drive system. The engine drives a total of only 4 gears in the main transmission, with 2 gear meshes. In the tail rotor gearbox, there are 2 gears and 1 gear mesh. The tail rotor drive shaft is one piece, lightweight and dynamically balanced. It has no supporting bearings and no universal joints. The simplicity of the drive system provides lightweight, low power loss, and a minimum of maintenance. The four-bladed rotor system produces high lift with very little vertical vibration and rotor feedback. The blades are retained on the hub by laminated stainless steel straps. The OH-6, the highest performance light observation helicopter in the Army's inventory. You will soon be flying this LOH. Obviously, the OH-6 is a fast, powerful, responsive, and stable aircraft. Let's see what gives the aircraft these desirable qualities. The OH-6 is small. Its total length from the forward edge of the rotor disc to the trailing edge of the tail rotor disc is just over 30 feet. Its rotor diameter is slightly more than 26 feet. This compactness gives the OH-6 excellent close-quarters maneuverability. The aircraft has clean lines. The teardrop-shaped fuselage is the result of wind tunnel testing to provide minimum drag. Even the landing gear struts have fairings to reduce aerodynamic drag. The clean lines of the OH-6 are part of the reason for its speed and stability. Another contributing factor is the powerful, lightweight turbine power plant. The small turboshaft engine weighs only 130